Welcome to the video lecture series. In today's session, I will be explaining about the compacting equipments and field compaction control. Compaction is a process of removing the voids which is filled with the air. Here, in this process, we use different type of equipments. Why? Because the single equipment is not capable of compacting the different type of soils. Here we use rollers and rammers as well as the vibrators. In this picture you can see we have rollers. It is also called as the smooth wheeled roller. And the next picture is the rubber tired roller, and the third picture is the sheep foot rollers. Here, one method of compaction is not suitable for all type of soils. If I consider the black cotton soil or a clayey soil, you cannot compact the black cotton soil or clayey soil using the smooth wheeled rollers. It is suitable only for the gravels, and this sheep foot rollers is used for compacting the clayey soils and other sticky kind of soils. Hence, we need to adopt the right method of compaction to achieve higher density in the field. And this tamping rammer, right? So, whenever we have the space restrictions, in that case we can make use of the small equipment like tamping rammer for compacting the soil. If you want to compact the soil which consists predominant amount of sand, then the types of compacting equipment whatever I have showed is not useful. Whenever we want to compact the soil which consists predominant amount of sand, then we have to go for the method of vibration. In this picture you can see this is a vibro float, right? So, using the vibration it helps in compacting the sandy soils. Coming to the compaction, here we need to understand two important characteristics of compaction. One is the optimum moisture content and another one is the maximum dry density. In this picture, the x-axis is moisture content and y-axis is the dry density. And you can observe the compaction curve. Here, optimum moisture content is the water content which is corresponding to the maximum dry density, and the maximum dry density is the densest state up to which you can compact the soil. Here, knowing optimum moisture content and maximum dry density is very important when it comes to the field compaction. It will help you to when to stop compaction. You will get a good idea on when to stop the compaction, right? Here, the procedure for this is very simple. In field, what we have to do is measuring what is the moisture content and measuring what is the dry density. And in this picture, you can observe the density will be maximum only at the optimum moisture content. If the moisture content changes, the density will be other than the maximum dry density. Therefore, one thing is very clear from this: the maximum density can be achieved only when the water content present in the soil is equal to optimum moisture content. Therefore, we need to know what is the optimum moisture content for that particular kind of a soil and what is the densest state up to which we can compact that soil, right. So, here we need to follow the procedure like this. The first step here is to identify the soil from the borrow pits. Whenever we are using the soil for the construction of roads, we need to identify the right type of soil. Using the identification methods, we will come to know whether the soil is suitable or not for the construction of road, and we are bringing this soil to the laboratory for the determination of optimum moisture content and maximum dry density. For this, we have to run the compaction test and the result of compaction test will be the optimum moisture content and maximum dry density. Once we know this, then the soil is taken and it is spreaded in number of layers and it is compacted using the suitable type of a compacting equipment, like whatever I have told, the different type of rollers. Based on the suitability, we use different type of rollers and the compaction is to be done. And how to ensure that we have compacted it sufficiently is by running the test in the field, that is the measurement of in situ density. That is nothing but finding the density of soil which is achieved in the field. Here we can rely on the core cutter method as well as the sand replacement method for the determination of in situ density. That once again depend upon which type we have to go for is dependent on the type of soil. If we have more sandy kind of a soil, we go for the sand replacement method, and if it is possible to take the core sample out of the soil, then we go for the core cutter method. And using those methods, we will come to know what is the density which is achieved in the field. If the density achieved in the field is less than the density achieved in the laboratory, it will tell you that still compaction is to be done. And here one thing we need to be very careful, that what is the moisture content at the time of compaction we need to check. If we are compacting the soil when the moisture content is other than the optimum moisture content, it is not possible to obtain the maximum dry density. Therefore, we need to check before compaction what is the moisture content which is present in the soil. And if the moisture content is equal to optimum moisture content, then if we are rolling, then we can achieve the maximum dry density in that soil. And once we know what is the density, if it is not sufficient or if the density achieved in the field is less than the maximum dry density, then it is indicating you that further we need to compact the soil. And after several number of roller passes, once again we have to check what is the density. If the density achieved in the field is equal to the maximum density or maximum dry density which is achieved in the laboratory, it is telling you that further increase in the roller passes will not help you in compacting the soil. Why? Because the soil is already compacted 100%. Thank you.